Hello everyone, my name is Junlin He. In today's video, I'm going to present you the topic Neural Style Transfer. The idea and algorithm in this presentation come from the paper A Neural Algorithm of Artistic Style. So what is neural style transfer? It can be defined as transferring the style of an image into another image using neural networks. For example, we have an image here, a dancing woman, and we have another image here, a painting from Picasso. Now, what neural style transfer does is to extract the content from this dancing woman image and the style from this painting, and then combine them to get a reconstructed image showing this dancing woman in the style of this painting. We call this dancing woman image the content image, and this painting the style image, since this dancing woman image provided the content and this painting provided the style. Due to the visually plausible results, neural style transfer has been applied in some industrial applications successfully, mainly entertainment applications, and has begun to deliver commercial benefits. So how to use the neural network to extract the content and style from an image? To do this, the paper's authors used a pre-trained convolutional neural network. Here is a typical structure and the working process of a convolutional neural network. As you can see in this example, the content image with shape 3 by 512 by 512 is transformed into different shapes at each layer of this network. To extract the content of the content image, we use the output of a layer to represent the image's content. In the paper, a layer named conv4 was used to extract the image's content. After that, we transfer this extracted content to the reconstructed image. To do this, we first initialize the reconstructed image as a white noise image. Then we pass this white noise image to the network to get its content, using the same method we just mentioned. Then we use the mean square loss between the content of the content image and the content of the white noise image as our content loss function. We train the network to minimize this loss function using backpropagation. During the training, we don't update the weights and biases of the network. Instead, we only update the pixels values of this white noise image. Eventually, this white noise image will have the content of the content image. So here is an illustration of this process. So now we have talked about the content loss function. It helps us extract and pass the content of the content image. We also need a style loss function to help us extract and pass the style as well. Combining the content loss and the style loss, we get the loss function of the whole algorithm. Here, alpha, beta represent weights. They're just hyperparameters. If we want to emphasize the content, we increase the value of alpha. If we want to emphasize the style, we increase the value of beta. To construct the style loss function, first we need to be able to extract the style from an image. In the paper, the style is represented by the correlation between feature maps of a layer. So here is what I mean. Suppose we want to use the information from the layer conv1 to represent the style. We see that conv1's output shape is 6 by 512 by 512. So it has 6 different channels, or you can say 6 different feature maps. To represent the style using these feature maps, we calculate the correlation between each pair of these feature maps. So we calculate the correlation between the first feature map with itself, and then the correlation between the first feature map with the second feature map, and then the correlation between the first feature map with the third feature map, and so on. 6 feature maps have 36 permutations, so we need to calculate 36 correlations. After that, we put these 36 correlations into a 6 by 6 matrix. And this matrix is what we use to represent the style of the input image. So this is how we get the style of an image. Here is the detail of calculating the correlation between two feature maps. Suppose now we want to calculate the feature map between these two feature maps. First, we do an element-wise multiplication between these two maps. Then we sum up all the entries of the resulting matrix to get the scalar value. And this scalar will be the correlation between these two feature maps. In fact, this is a 2D correlation. We have learned this in the course. So using this method, we extract the style for both the style image and the white noise image. The mean square loss between them is our style loss function. We minimize this loss function during the training. Eventually, the style of the style image is transferred into the reconstructed image. Also, one thing to notice is that in the paper, the whole style loss is represented by combining the style loss from several different layers. The reason is that the paper's authors find that this method yields a better result. So that's the complete introduction to the technical details of the original neural style transfer algorithm. The algorithm I showed in this video is the first proposed neural style transfer algorithm. After that, many new algorithms have been proposed. Some of them have faster transferring speed, some of them have more appealing results. I have listed several new exciting methods in case you are interested. So that's my entire presentation. Thank you for watching this video.